This is Geometry, Lesson 12.2, Finding Sides with Trigonometric Ratios. Before I do the first example, I want to review the trigonometric ratios. The first one we talked about was sine, and we said the sine ratio was the length of the side opposite from the hypotenuse, or opposite from the angle, divided by the hypotenuse. The second ratio we talked about was the cosine ratio, and that was the length of the side adjacent to the angle divided by the length of the hypotenuse. And the third ratio we talked about was tangent, and the length of the tangent, or the tangent was, the ratio was the length of the opposite side from the angle divided by the length of the adjacent side to the angle. So I write SOHCAHTOA as a little shortcut to help you remember my ratios. The first thing I want to do on this example is label my opposite, my adjacent, and my hypotenuse. I like to label the hypotenuse first. Remember, the right angle always points at the hypotenuse. Whatever angle we have marked is going to help us determine our opposite and our adjacent. We label the opposite from that angle, and then the adjacent is the closest one to that angle. We label the opposite, adjacent, and hypotenuse, but we're only actually going to use two measurements in this case. So if you notice, the hypotenuse is next to the letter x, the opposite is next to the number 10, and that adjacent side doesn't have any information, so we're going to ignore the adjacent. We're only going to work with the opposite and the hypotenuse. And that's how we're going to choose if we should use sine or cosine or tangent. So since I have an opposite and a hypotenuse to work with, I'm going to choose sine. It's my only ratio that I can use those. I'm going to write sine of the angle, and in this case my angle is 65 degrees, equals, and I'm going to write my ratio. My ratio is the opposite over the hypotenuse. My opposite side is labeled on the 10. My hypotenuse side is labeled on the x. And now I'm going to do one more thing, which you don't really need to do, but it makes it a lot easier. I'm going to put that over the invisible 1. What that does is it gives me two fractions equal to each other, which we just talked about in chapter 11. That's a proportion. And when I have a proportion set up, I can use cross multiplication and I can determine what x is. So I'm going to multiply 10 times 1 divided by the sine of 65 to bring me to my answer of x. 10 times 1 is still 10, which is why that over one step isn't super necessary, because 10 times 1 is still 10. But then we do 10 divided by the sine of 65 degrees, and we just got to put that in our calculator. If you are using your own personal device, you need to make sure that your calculator can handle degree mode. If it's only got radian mode, then you'll need to find another calculator. My calculator is already set up in degree mode, so I can do 10 times 1 divided by the sine of 65 degrees. And when I hit enter, it's telling me that the length of x, my hypotenuse, is 11.0. I guess I don't have a unit, do I? Centimeters, inches, doesn't say. 11. And that's it. I'm going to go to example B, and we're going to do kind of the same thing. We're going to label our opposite, our adjacent, and our hypotenuse. We're going to choose sine, cosine, or tangent, and then we're going to cross multiply and divide. So I'm going to start with my hypotenuse. My right angle points at the hypotenuse. My numbered angle is pointing at my opposite side. And then the side closest to my numbered angle is my adjacent. My opposite in this case is blank. My adjacent has an x, my hypotenuse has a 20, my opposite has nothing. And if I'm left with an a and an h, I should know to choose, too far. If I'm left with an a and an h, I should know to choose cosine. Cosine is my only measurement that will let me do an adjacent side, and a hypotenuse. So I'm going to choose the cosine of the angle, and I'm going to just throw that over 1 right away. My fraction is the adjacent on top and the hypotenuse on the bottom. So I put x on top because x is on my adjacent side, and I put 20 on bottom because 20 is on my hypotenuse side. And I want you to be careful not to get into the trap of always put the x on top or always put the x on bottom. You set up your ratio, your fraction, based on your SOHCAHTOA. Example A, I had x on bottom. Example B, I have x on top, and it's based on the fact that the hypotenuse goes on the bottom. Here my hypotenuse was x, here my hypotenuse is a number. Hypotenuse goes on the bottom. So once that's set up, I can cross multiply and divide. I'm going to multiply this way so that I can point at my x. 20 times the cosine of 55 degrees. And then that divide by 1 is kind of extra, but I like throwing all 3 steps in there. I just got to put that in my calculator and see what that length is. 20 times the cosine of 55 degrees. Make sure you close that parentheses. Divided by 1, 11.5. One more example quick. We're going to label OH and A, choose sine, cosine, or tangent, set up a ratio, and cross multiply and divide. So I'm going to label my hypotenuse first. I always feel that's the easiest one. My 25-degree numbered angle is here, so my opposite is way over there, and my adjacent is right next to it. This one's kind of misleading because I kind of see a number by the O, I see a 12 by the O, I see an X by the A, and there's kind of a 25 degrees by the H, but not really because that 25 degrees is inside the triangle. The H is blank. If I have O and A, I'm going to choose my tangent ratio. We do tangent of the angle over 1, and then TOA means I put my O, my opposite, on top, and my X on bottom. And then we can cross multiply and divide. 12 times 1 is still 12, divided by the tangent of 25. Go to my calculator, and I have 12 times 1 divided by the tangent of 25, and that brings me to 25.7. That is it for the notes on this lesson. Good luck on the exercises, and please let me know if you have any questions.